Today, we are building a 500 horsepower 2011 STI. This is a customer named Tanyan. He's been a really reliable customer to me for the past couple years. We've been chatting back and forth since we did the original mods on this car about kind of going the next step, doing an upgraded turbo situation, front mount, that kind of thing. I had parts ordered. We had the turbo, the intercooler, and a couple other items that we are going to install on his stock short block STI. Long story short, we bought all the parts. We agreed on everything. Drops it off to me and he says, hey, look, I've noticed some coolant spray when I go and drive it really hard. You know, I thought, oh, maybe the radiator cap is bad. There might be a loose connection to the expansion tank. So we went and drove it within 5 minutes and you could see the expansion tank just bubbling like crazy. The head was lifting under boost. The factory head studs and head gasket had basically gotten to a point where the coating had failed and it was pushing combustion gas into the coolant chamber. Long story short, we went ahead and pulled the trigger. So let's go through the build list on this car. It's pretty extensive and the car was already modified. So essentially the car came to me back in May of 2022. We did an STI top mount intercooler install, then we did BC coilovers, and then after that we started talking about what mods we could do to it. It already had an intake and a high flow downpipe and a catback, so it was basically stage 2, but we were looking for a bit more power. So then we switched over to the Cobb next gen flex fuel kit. It's been at that stage since we did this build. To its credit, full E85 flex fuel build stock turbo is probably my favorite combo for a car that's driven regularly. Tanyan doesn't drive this car very often, so he likes to go look at it in his garage. Anyways, he wanted more power, and that's where we start getting into the conversations about what our limitations are with the factory block. E85 stock turbo is really where I like to keep them. They're really happy there for a long time, and we don't see very many pattern failures, but it's when you go larger turbo E85, we start pushing the limits of what this factory block can handle. It had about 80,000 miles on it, so you know, we were playing with a block that was already seasoned, so it's just kind of a matter of time. So we decided to go the route. We were going to do a DOM 3.0 full E85 flex fuel running 1300cc injectors. It has the AEM 340 fuel pump in it, and it's hardwired. And that was to a point with the DOM 3.0 that we could make enough power and torque. We'd be detuning it a little bit to keep the stock block happy. So then our build kind of exploded from there. We decided to go the IAG closed deck, roughly rated about 750 brake horsepower. We did the Blausch Dom 3.0 competition stage 3 clutch we put in it. We went with the Cobb front mount intercooler, and that's kind of where we were going to stay. And then Tanyan reached out and said, hey, like, we're already here, can we do an intake manifold? Absolutely. So we added on the AMS intake manifold that you see. And then we were talking about some limitations we have with staying stock ECU with Cobb green speed. You know, we're already here, let's convert it over to link ECU, get some more functionality and safety in there. So the car is fully converted on link ECU with fuel pressure and CAN lambda for safety. You know, this build went from pretty standard build to it kind of exploded. It needed a brake fluid flush badly. I'm sure we can put a photo of the fluid on that one. For the most part, it's a pretty solid build, but TLDR, you have the IAG 750 closed deck, the ARP 2000 studs. We went Killer B equal length header, Cobb 4-bar manifold pressure so we can really up the boost so we're not limited to the stock map sensor. We went new turbo inlets, then we converted it over to speed density so it has an intake air temperature sensor connected into the intercooler piping, and then we converted it from a street series aerial separator to a competition series simply because with the new intake manifold it's a bit harder to run the PCB line the way that it's supposed to be. So all of the ports on the intake manifold now are on the bottom of it instead of the back. Other than that, there's some miscellaneous stuff. We need some 5/8 T's and some fittings basically to convert the factory AOS routing to the intake manifold. And then we had to rotate the throttle body 90 degrees and add a suspension harness onto that. you, Steven. Add an extension harness onto that to get it to fit. And basically after that, we loaded a break-in tune on it. This is a really, really solid setup. What's nice about this build is Tanyan is basically set up to where if he gets tired of the Dom 3.0 and wants to make more power, essentially all we have to do, go to a rotated turbo setup and add a bit of fuel system. We'd have to upgrade the injectors from a 1300 to like a 1750 or somewhere around there. If he wants to make 600 or 700 horsepower in the future, it is pretty straightforward to do so. Custom ECU, custom fabrication and assembly and tuning. So this is like a really solid example of the big projects we do here, besides the maintenance and stuff, which we still do because that pays the bills. While Steven attempts his first ever bumper trim under supervision, I will be assembling a motor.
Screw the C, dude. Let's go look at that.
You just want an excuse not to cut that bumper, don't you?
Isn't it bad to run them outside of water? 2 p.m. tomorrow. I'll have this on eBay for anyone who wants it. I'll sign it. Piece of a bumper.
Easy, right?
Kind of.
I already know it's not gonna fit. So all of this has to go.
My neck.
Obviously I have some cleanup still, but let's see if I made a dent. Measure once, cut 6 times. That's still hitting there, isn't it?
Yeah.
It fits. Not really, I still gotta cut it. It's on. That's a lot of intercooler. When you get a link from me, how we do the installs. And this is the bare minimum. The big thing here on the Link G4X is the plug and play ECUs. So when you get it from Link, you will have the big box here. Product registration, if you're with me and you order it from me, since I'm a Link dealer, I can handle all that. You're gonna be a little confused when you get it because it's kind of like unwrapping a motherboard. If you ever built computers, this is your Link ECU. You notice it has the same kind of USDM connectors, just like the factory ECU would, but all you get is this board and the USB connector doober here. This is what it looks like. That's all it is. And you have your different headers here. So depending on your configuration, you might have to change your jumpers depending on different model year variations and stuff like that. And then you have your different adapters. So you have your USB cable adapter. So we leave this plugged in the car and we just tuck this usually underneath the passenger floorboard area. So when you connect to the car, you want to connect to the Link and tune, you're basically just going through a USB port. Next, the other big thing that is a requirement from us every time you do a Link ECU is a thing called CAN Lambda. Link sells the entire kit. Essentially what this is you can see it has, that's the controller there. We'll mount this in the engine bay when it's time. And you have a standard Bosch style wideband connector. You have the wideband itself, the actual sensor, and you have the Deutsch connectors, oxygen sensor bung, and a plug, and all the minor accessories. So on Subarus, the front O2 isn't good enough for us when we do custom tuning. We always like to have a wideband because we can read, number one, after the turbo, and two, we can read lower than the factory sensor can. So this setup, the CAN Lambda and the Link are always together when we sell them. But essentially this acts like a wideband that is directly connected to the Link through CAN bus. It's about $350 or 400 bucks. There are other options like widebands that allow you to have connectivity with the Link, but in my opinion, it's better just to use the one from Link. The other stuff you'll get when we do a Link ECU install on your car, this is the expansion loom. If you ever worked on any type of small electronics, I'm sure you're familiar with these. Essentially, this will plug into one of these headers here, and I ordered 2 of them. If you can see the text there, these are programmable. So essentially, we use the expansion loom to hook up various sensors to it. The other nice thing, like let's say you have already in the car fuel pressure, oil temperature, you name it. Usually on every gauge, they'll have a voltage output that is basically used for data logging. You can tie it into one of these expansion looms and then set the scaler in the Link software and be able to basically monitor that directly through the Link. And once it's monitoring that data there, you can set basically a safety. So if I set one of these inputs to, I don't know, oil pressure, based off the voltage reading that the gauge is telling me, we can put in a safety. So if you're wide open throttle and suddenly you lose oil pressure, well, the Link knows that and it will try and, at least partially save the engine. Anyways, you get one of these. I order 2 for every one because there are technically 2 expansion pinouts. So there's your second one. And then thirdly, you need a CAN connector cable. You notice on your Link, there's your CAN connector. So essentially that is what's happening there. So you have to have one of these. This is about $47. So you need a CAN connection cable for the plug-in ECU. So these 3 things, mandatory requirement. I will not install one on a car and tune it without these 3 items here. And the only other real fancy thing that you can get, which we like to, these Deutsch connectors. So these are a beautiful little invention. We have all the hardware to make our own pinouts and wiring harnesses. So essentially you have your pins and they go into the connector there. This is my favorite way to hook up our new sensors. Let's say we're doing an ethanol content sensor. We can buy these. They're not cheap, I'll be honest with you. They're about $5 to $7 a piece, but they make a really beautiful weather-tight connection that is easily serviceable in the future. So we basically just make our own harness and connections there. This is, in my opinion, the best way to do this. Link has excellent documentation on how all this stuff works. This whole setup, parts alone, you're looking at $2,500 to $2,800 probably. The cost of the Link ECUs has gone up, I'm assuming because of tariffs. By the way, if you're a returning customer, if you want stickers, license plate covers from every single performance brand under the sun, these are free. The Cobb stickers, I just throw away. I have so many of them. If you order from me, pay online, I can send you a deposit. I could probably get you a Link in less than 3 days. This is for USDM WRX 11X. This is for, I believe, the 2008 and up STIs. It might be 2015 and up, I don't remember. Anyways.
Currently, Friday, June 6th at 11:43, right before lunch at Vendetta Performance. It's a little cloudy out. It's been sprinkling a little bit here and there in the morning, but it doesn't matter because we're inside the Vendetta Performance. Here we have the owner, Daniel Melick. Daniel, how does it feel to have a 5-star rating on Google?
It's not that hard to do.
Interesting. You heard it here, folks. That's what it's like to have a 5-star rating on Google.
All I gotta do is just be honest. Fresh pluggies, our beautiful IAG pan. See that right there? That is a crush washer. Now watch how I install this. So you ready? NGK plug. It's already coated. You do not put anti-seize on the threads. There is a crush washer on the spark plug. Watch. No anti-seize. Snug, right? There is a crush washer on the spark plug. Watch how much I turn this. I feel resistance. Done.
I usually just use the 1/2-inch impact.
People hit the crush washer and they're too afraid to keep going so they don't crush it and the spark plug is loose. You need about a 1/2 turn after it bottoms out to crush the washer. I'm sure there's a torque spec for this, but
it's 1/2 to 2/3 technically by spec. You put it on a quarter, you give it a little bit, and then you do 1/2 to 2/3 of a turn.
So you'll feel the crush washer squeeze and then that's how you know you're done. Oh, let's put the manifold on.
Exhaust manifold. We're going Link ECU on this car. Link doesn't use the OEM narrowband primary O2 sensor. Right after the turbo and the downpipe, there'll be a wideband sensor that plugs right into the ECU. So it will read way more accurately than it would otherwise.
My job here is quite important. More important than some would say than Liam's job right now. Lube that John up. John, if you're watching, I'm sorry. Yeah, I had the hardest job here, clearly. This is why I'm the lead tech at Vendetta Performance.
All right, we ready to lift this thing?
3,
It does not roll good, damn.
I need flex fuel connector, because this car is gonna be flex fuel. I need fuel pressure, flex fuel. I think that's it. The 19 STI, which we did a link install on 2 or 3 weeks ago, it's gonna be basically identical, minus that car had an oil pressure sensor. But we're gonna harvest the connector off this if I ever need this harness again. This car has a manifold on it, so we're not using TGVs and that kind of stuff. I can tee into those things instead of running extra harnesses, so that we will just basically run across and plug in. I don't have to do any wire running for that. So this will plug into pressure sensor here on the side of the regulator, so that you'll have an accurate fuel pressure no matter what happens right at the regulator before the injectors. So no matter what the fuel pressure is, it is always accurate. But we're gonna plug it into the TGV, which is over here, because we're not using that connector anymore. This is where the TGVs are at. There's a lower plate that's down here. We're not using this connector. There it is. So I will depin this side. This is the male side of the connector. Normally it tees into the female side. This side would plug into the TGV and then plug into the factory harness. So we'll plug it in the factory harness here, and I'll remove this section because we're not going to use it anymore because we don't have a TGV to plug into on the block. We'll then run it across over to the other side. I could also run it this way, but then I have to shorten the wiring and put splices in, and so we're just gonna run it across because it'll look the best. I'll tee it in and run it with all the wiring that's down underneath here so you won't see it. That's fuel pressure sorted, basically underneath and up through, and then it'll plug in right here. And then I have lots of wandering around because things are different places. The flex fuel sensor is buried, kind of hard to see, right here. So I need to run wiring, 3 wires. Takes a ground, 5-volt reference, and then a signal wire back to the ECU. And it needs to be grounded off the ECU, so I have to run all 3. I can't just ground it on the chassis someplace. So I need to run this from here. We'll run it back along the frame rail, up around the brake booster, and then I'll run it across with all the OEM wiring up here through all these clips and stuff. And we'll run it all the way over, across down here, and then I've cut a little grommet hole. If you cut an X in the grommet, you can fit the wiring through real well, and it will actually seal around it properly and not let water and crap in, and you can fit a bigger wire through. We'll run it through here, and then it will go down. The ECU is on the floorboard. The other wire that I need to run is for the CAN lambda, for the wideband for us to tune with. Link calls it their CAN lambda device. So you have the wideband sensor. This is for monitoring air-fuel ratios. This will go on that side where that grommet is, right on top, on the downpipe, right after the turbocharger. And so we get the most accurate fuel trims no matter what's happening, and it's not hot enough right there where we have to run what they call the Bosch advanced sensors. There's a lot of heat coming off the manifold as it comes up to the turbo, and once it passes through the turbo, it uses that heat to spin the turbine to actually compress the air. So after that, the temperatures cool down. Not where you can touch it, but not as much as it comes right out of the manifold. So you have to put this in, which requires these 3 things. The sensor, we need the controller, which is, you can see it right there, CAN lambda, and then we need the CAN expansion harness that goes into the ECU itself. And so that will plug in on the ECU. You have the box and you have the ECU itself. Right here it says CAN 1. The CAN 1 will go there. For easy visual representation, this is the expansion loom. This will plug into the board. This will allow us to have CAN bus connection, which allows us to use a bunch of different digital signals to talk with multiple devices at once and not run 3 designated wires to the ECU or however many this needs. So that will run off the board. I'll run a little extension harness through the firewall. This will then plug in on the car. Most of the time I mount it either right here or right here, or I tuck it away, strut tower. So we just have to kind of work around. Every car's a little different on what we have and what we don't have, and what parts are covering up what, and what's mounted where. And so you kind of have to play the guessing game. Not every car is going to be exactly the same, but I like to put it in this general vicinity because I don't have to run much wire. The ECU is on the floorboard right down there. Wire runs up, runs through here, And then if I mount it right here, I don't have to do much. I don't have to run it across the car or wherever else because the sensor is gonna literally sit right there. So that'll simplify everything. We don't have to run the factory narrowband O2 sensor that's in the actual header on the bottom. Sometimes we'll leave it in the car just as a plug because it does better than some of the other smaller plugs. They don't back out because they have a proper crush washer. And that's pretty much it. So just fuel pressure, like I said, flex fuel in the corner over there, and the wideband O2 sensor for the CAN lambda device that's right there. The rest of it is all plug and play. The ECU plugs into the factory harness. We'll run the factory engine harness off the car and run everything else. So we don't have to do a whole bunch of custom wiring and looming and all that other stuff. It fits in the factory housing for the engine control unit. You cut a few holes so the extra wires will fit through and whatnot. The only other thing that we have to run is the USB connection cable, but that's all in the interior. I just pull some stuff aside and tuck it up underneath so you can actually connect a laptop to the ECU. And that's it. We'll remove the Cobb Next Gen Flex kit because we don't need that anymore. That's pretty much the whole shebang. Right now I'm just gonna set the wires in there so when the engine's in it, it's easier for me to run stuff, but I can't set anything in stone until the engine's in the car. I'm only using these 3 wires, so I'll take these, wrap them, so we have them, because I don't want to cut them off. Who knows? He may want to expand stuff, he may want to make more power. On this specific expansion harness, where this is going to plug in the ECU, one of these is a knock sensor edition if you want it, and the other 4 are injector outputs. So you could have a dual stage injection if you wanted to. So you could have like a smaller set of injectors down here to like idle and do all your low boost under 8 PSI, 10 PSI. And then you have a second set of injectors that kicks on at higher boost pressures to add supplementary fuel. Because when we start getting to like 2200 cc injectors or even 1700s, the car doesn't idle very well. But it drives really good with the smaller injectors because they have more resolution. You can actually tune in the small sections, but then you run out of injectors. So you have to add some extra on top. So the cars will drive a lot smoother that way. I gotta cut a hole for the CAN expansion harness to go through the top of the case, for this expansion harness to go through, and for the USB port to go out the back. And so the USB will run out the back side, up, and then I'll run it. You can't see it, but along this trim piece down here, tuck it up underneath, and then you can kind of access it if you're in the passenger seat. But otherwise it's tucked away, you can't see it. And the rest of this will be all underneath the carpet. You'll have no idea it's there. And so we'll get all that buttoned up. Is this the best way to do it? Probably not. But last way I did it was a pain in the butt. See how long this lasts. I don't have a Dremel. This is what I'm doing.
You've got to be f***ing me, bro.
Dude, you've got like 15 of them. There's like a bajillion. They're just very, 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 very fragile. But they work really good.
Oh, they do.
I don't think he's very amused.
So I took the throttle body off so I can not damage it or the manifold. I gave it more room to try and keep this off of it. It's a little catty-wompish right now, but that's fine. Race car. It's a race car. Remember that, race car. Putting on my plates here. That's where you pull the wrist pin out if you split the case. Nice.
Is there easier ways to cut it? Probably, but does that look the best? Yes. The last time I did it, I just kind of dremeled it with the carbide bit and it looked not great. That looks pretty good. So now you can see there's my expansion harnesses and the CAN lambdas back there, or the CAN bus connections back there. So when I slide this in, there's nowhere for the wires to go once there's a front plate on that. So I'll cut a slit right here so I can plug all those in and unplug them if I need to pull the ECU out, and have enough space to get a screwdriver in there to pop them out. And then we'll be good. Install it in the car and wire some stuff in.
You see the arrow? Yeah, that's where the thread locked bolt goes. The more you know. After this, got a rear main, flywheel, clutch. This is really gonna piss some people off on the internet too.
So I have enough space to get on there with a screwdriver and tap the release button to pop them out. They're tucked so close to the edge that I have to leave some structure here, otherwise the case isn't very strong. It doesn't have to be, but I try to let it be. So that way, when I get in here, I can, inside the car, place this in the box, click it in, then I can get in there with either my finger or a screwdriver, and there's a little release point right there where my top of my finger's at. So I can get in there and go boop and pop, and now I have it out. And I can put the CAN bus one in, I can put this expansion harness and that expansion harness if we ever decide to put a second one in there. So it's groove on both sides. One side of that's thin and one side of it's thick. There's more space in the bottom than there is on the top. Clicks in like this. And there's 2 clicks on the bottom. Here we go. That's all in there. Looks like OEM besides the fact that there's a hole there and a hole there. CAN expansion piece, go on the top, plug that in just like that. It's clicked in there. And I have the USB for us to hook a laptop into it. Goes in the back of it, upside down, clip on the bottom, just like that. Now the other expansion harness is in the car. That's actually going to be in this one. So put this in, bolt it in, put the expansion harness in it, connect all the connectors, verify that it powers on once we get the engine in the car. Before I do any other wiring, make sure we don't have a bad ECU. Go through, finish the wiring up, tuck it all away, and we'll be good to go. Get a base map on it, and start it. I do have my pinouts. So the CAN lambda is going to be in CAN 1. Fuel pressure will be in TGV right. So the signal wire will be there. It'll get power and ground either way. Flex fuel sensors will be in DI11, which you have 2 expansion harnesses. This one here, this one here. This one is ground, 5 volt reference, temp 4, temp 3, volt 4, volt 5, volt 7, and volt 8 in this front one right here. They're labeled. You can kind of see it, the labeling inside of there. So the secondary one is ground, 5 volt reference, knock 2, DI11, injector 5, 6, 7, and 8. And so I'm going to use the DI11 because the flex fuel sensor uses a digital input. So I need the ground, because I need to ground the sensor. I need the 5 volt reference to power the sensor, and then the signal wire, which is the DI11 signal. And so those are the only 3 wires I'll use out of that expansion harness. And so we'll wire them in there. It's in the pinouts if you go look it up online too, but that's how I know which one is what, because they label them. And that way I can add whatever I need to. Oil pressure, sending unit, that kind of stuff, without using the stock wiring, in case you're using all the TGVs and everything else in the stock harness.
Nothing like bending over, cleaning the shaft, bro. Segmented ceramic clutch, competition clutch. I run a similar setup in the BMW. What's funny about these ceramic ones is you can actually hear outside the car when the ceramic plates actually make contact with the pressure plate and the flywheel. I don't know how to explain it, but you can literally hear it when they start to make contact. It's got some pedal feel to it, but it's not terrible. If you screw up the takeoff, it will chatter at you. It will bark at you when you do it. As you can see, the engine is now in the car. It took a lot longer than we expected. The custom intake manifold and all the stuff to get this to fit with the new front mount and everything, a bit more work than I had anticipated, but it is in the car. It has fluids in it, coolant, oil, power steering fluid, everything. We have set up the link ECU, done the wiring. So we have our intake air temp sensor there, run through. We have our ethanol content and our fuel pressure connected to the link. We set up the link just to do kind of a dry fire. So we made sure we cranked it, got oil pressure, and it's kind of sat since then with all that. We got the front mount fitted and the bumper actually cut so it actually fits. We cranked it, built oil pressure, and then I noticed this morning, we're about to start tuning on it, that it had a little drop of oil on the ground. Found out it was coming from the turbo feed. This isn't a super uncommon issue. The aftermarket feeds with the banjo bolts sometimes don't fit the way we want them to, but I think we have got that figured out, hopefully. I just took the hot side piping off and reached down there and adjusted and tightened some things. So fingers crossed we got it fixed. If not, I'll have to go in and adjust it even more. But we're kind of at the point now where we've already dry fired it. We know it has coolant and everything. We're basically ready to try and start it. And I'll get to verify if that leak has been fixed or not. We'll know right away. Now we're just writing the base map for the car, and this will be an actual first fire. All we've done is crank it. I'm a wee bit nervous. I always get nervous when I do builds like this. There's a lot of money here. So hopefully it all goes smoothly and I don't have to tear the whole damn engine. engine apart again. Besides that, if you plan on going custom intake manifold on these cars, it doesn't matter if you go AMS or the Process West, there is a lot of extra work added to the install. It's not a simple just drop it in and go. All of the PCV routing has to be redone. All of the vacuum lines have to be redone. And there's some fitment issues. We had to get creative with the front mount piping. As you see, we had to rotate the throttle body 90 degrees to even get the dang thing to fit with the front mount. In the future, if I were to do this again, we've already kind of talked about it. It has an IG 750 block in it. The next step from this realistically is we'd talk about doing a rotated turbo setup. And with the rotated turbo, we can make 100 extra horsepower, but you lose the low end drivability that people really like. So we'll see how this setup runs. I'm confident it's going to be a really, really nice car to have fun stoplight to stoplight while making somewhere in the 500 horsepower range with E85. One more time. Success. Success. That's right, bitches. Now let's see how much oil we dripped out just from cranking it. You know what? At least we know the turbo has been well oiled. It has been pre-lubricated. It's ready to start. Oh, something funny. To make this work without doing a whole bunch of custom fab, this pipe is actually supposed to be on that side, but it wouldn't work with the intake manifold, fuel pressure regulator, all that in the way. So I had to change the pipes around, but I didn't have to cut up these nice powder coated parts. So that's a win. By the way, if you ever have anyone build you a motor, do not pick up said car with a fresh short block in it and immediately drive 9 hours to some vacation or trip you want to go on. That's the worst way ever to break in an engine. Like 6 hours straight of just constant 2,500 RPM on the highway. Yeah, terrible. And on top of that, what if something starts to leak? Like the engine was just done. This manifold shifts everything to the back. Obviously, it's a larger runner. Comparison, like side by side, it is a much bigger manifold. I don't know what you'd call these things. These chodes. They shove everything back. We just had to get creative, and part of it was getting the blow-off valve down 90 degrees. This intercooler piping, this is supposed to sit below, but because of the fuel pressure regulator, you can't stick it down there because it's in the way. So we had to basically lift it up and then switch pipes around to get it to work. How many times I see stickers on cars with this shit still on the sticker. You can already see where it was leaking. Come look at this one. You can actually see where it's been dinked. It looks like it's kind of crushed in. Every single NVIDIA exhaust does it. So on the 3-inch ones, you can clamp these two, but then it leaks out the bottom. So fucking stupid.
Why now? Well, double gasketing this exhaust because it leaks, as per usual. This build will never finish. I'll never be able to go back to my dungeon where Daniel keeps me. So as long as the camera's out, I have to be at the shop. Tuck all the wiring. What link ECU? Now that the interior is all cleaned up and ready for him to look at and be like, wow, what a great job Vendetta Performance did quite again on a link ECU install. We can move on to the front of the car where we can't open the rag cap yet because the cars are around 210 degrees Fahrenheit. So we stare at it until it gets cooled down.
She's pretty full, dog. She does purr. Sounds good. Really, really healthy. Check out my USB port to plug in my race car to my laptop. Honda boys with laptops better be ready. And we're off. There is some getting used to on this clutch because it's not broken in yet, so. And we're still on base map. It has a little bit of rev hang between gears that you have to get used to, but this thing is going to be a rocket ship when we're done with it. Hit rev limit there. The other thing I'm looking at is that number on the bottom right. that lambda fuel correction. It's the correction to get to the target AFR. So like, what's our lambda, like 4 point something? Yeah, we're doing, that's really solid. And you'll notice that like certain spots, like when I let out, it cut fuel. For a base map, like Graham always has these things fucking nailed, dude, every time. What's my coolant temp, 198? Yep. Yeah. And what's cool is the Link still allows you to have your different drive modes. So sport, sharp, and intelligent. So all the drive modes still work. This thing drives solid, man. I do think we could raise it up a 1/4 inch.
206, by the way.
And like 206 to 210, really, it's like, that's not even overheating. But I could definitely tell the front mount is impeding some airflow there to the radiator, because like the fans kick on at 190 with this setup, the way we have it set up. So the fans are on and we're driving and we're about 200, which is strange because like when we were sitting, I didn't see more than 210, but now see us going back down. So in this scenario, I'm just going to keep the car another day and just drive this and make sure it doesn't do any weird funky shit. Yeah, now we're at 202. Yeah. Give it some real drive time. And I want to give it a little boost too to make sure the expansion tank isn't leaking or anything. We have it really, really tame right now, 203. That might just be where she wants to stay, man, is 200 to 210. Because like normally I see the temp go down when we accelerate, like when we get some air moving through the radiator, but it doesn't really change that much. It actually goes up. And I think it's because of the front mount. Oh yeah. This will be a certified ripper. So I'll take it on the highway tonight, really see what it's doing. The only other option, it already has a CSF radiator in it, to cut the opening for the front mount bigger. That's really the only other option to keep the temps down. But it's what, it's like 90 something degrees today. Like single digit 200s for a 90-degree day, that's not terrible. I call that a win. If you liked watching this build process or like Subarus in general, or if you need parts, reach out to me. I'm basically a wholesaler for every good known reputable Subaru aftermarket brand there is on the market. Or if you want to build like this, reach out to me. I'm more than happy to take care of you.
Please like and subscribe on the video and leave a comment so we can see what you guys think. Thank you. Parkour.